Hi guys, today we have Leetcode Biweekly Contest 81 and let's see how it goes. Come on. Whoa, 3, 5, 5 and 6. Okay. You're given a string S where every two consecutive vertical bars are grouped into a pair. In other words, the first and second bar makes a pair. Okay. Number of asterisks in S excluding the asterisk between each pair of these. Number of asterisks. So 2 here. Okay, okay, okay. Is, yeah, initially is true. Then for each character in string, if it is a bar, then flip the value of f, right? Else, mm, if character is asterisk and f is true, then do answer plus plus, else don't do answer plus plus, and then just return answer, I guess. Hmm, wait, what? I mean, if f then set f equals to false, else f is true, but I don't think that was the issue. Then we are flipping, else if it is an asterisk and f is true. Okay, so maybe that was the issue. I was just trying to be over smart, I guess. Count unreachable pairs of nodes in an undirected graph. You are given an integer n. There is an undirected graph with n nodes numbered from 0 to n minus 1. Given a 2D integer array edges, number of pairs of different nodes that are reachable from each other. So I guess just a connected component. Number of pairs of different nodes that are unreachable. Oh, but still, I guess number of nodes minus the size of the current connected component. So like in this one for 0, the answer should be 3 by 2, or since we are talking about pairs, so 3C2 I guess. So that will be 3. Oh, so 0 1, okay, 0 3, 0 6. Oh, like this. Then 1 0 they are not considering, right? Okay, so it is like one way. Hmm. Connected component of like this 0 and the numbers that are not in this connected component, which are 1 3 and 6. But then how will I think of this thing. This like when I am considering this one, I should not consider this zero. I think for that we can pre-process that thing. Wait, how? For this one, 3, 2, 3, 4, 5. These 5 values will be there. These 4 values will be there. Then for 3, all the values except 0, 1 and 2. Hmm. Okay, so I think I got an idea. Hmm. Let's create the graph. So okay, let's call these as switches. Auto en ed edges of e of 0 dot push back e of 1. Okay. Hmm. IDs and and let's call this as ID. If it has not been visited, then run a DFS edges and I and have to pass visited as well as IDs. Or maybe CC is not required as such. But like still the thing is same. How will I identify that out of all the remaining values? I mean I can do a segment tree thing as well, but that will be an overkill. Okay. So here what should I pass? Instead of this, let's have a vector of count, initially 0, void DFS. I think, yeah, one thing was missing. ID. So visited of current is now true. CNT of ID plus plus IDs of current equals ID. Right now for all children in edges of current, if they are not visited, then do visit them. IDs and ID. And then okay, let's call it as some count of ID, and now do ID plus plus. I should initialize it with a 0. Okay, and now I less than n I plus plus. So answer plus equals to sum, or sum minus CNT of I, right? Right. And do CNT I minus minus and sum minus minus. I think this should work. Visited is not defined. Okay. 3 and 21. First one is a 0. Yeah, it should have been a 0, right? But wait, what's going on now? 0, 2 and 3. No. What does this say? 3 only, so that thing is right. But oh, this is not CNT of I. My bad. This is CNT of IDs of I. Yeah, and then this is also this. Okay, let's see now. 0 and 14, yeah, that was the answer. Yeah, cool. Maximums are after operations. 0 index integer and nums, any non-negative integer x, and an index I. Then update nums I to be equal to nums I and which is bitwise and nums I XOR x. Noted and is okay. Return the maximum possible bitwise XOR of all elements of nums after applying any number of nums. Okay. So first take the XOR, then the resultant should be AND with the current num. 。   .
Num. 。  . 。 . 。 . 。 . 。 . . . 。 . . . . . . . . . 。 . . . . . . 。 。 . . 。 。 . . 。 . 。 . 。 . . . 。 .
0, 2 and 3. and we want the maximum possible bitwise order of all elements of nodes. Okay, let's see the last problem as well. Distinct role sequence. You roll a you roll a pair six-sided dice n times. Determine the total number of distinct sequences of rolls possible such that the following conditions are satisfied. GCD of any adjacent values in the sequence is equal to 1 of any adjacent values in the sequence. There is at least a gap of 2 rolls between equal valued rolls. Gap of 2 rolls. More formally, if the value of the ith roll is equal to the value of the jth roll, return the total number of distinct sequences possible. 1, 2, 3, 4. Okay, so the second condition is like this. So 1 is at index 1 and index 4. Difference is more than 2. And the GCD is always equal to 1, and they are saying any adjacent values, but the GCD should be 1 in the case of any, like the two neighboring elements should have a GCD of 1. So how many will start from 1? And n is given by them. In the case of 2, the answer is 22. Like for 1 it will be 6 obviously. For 4 it is 184. So like 1, 2, 1, 3, 1, 4, 5 are starting from 1, and then 2, yeah, 2, 1, 2, 3, 2, 4, no, not 2, 4, 2, 5. 4 are starting from 2. For 1 there are 5. For 2 there are 3. No, not 3, 4. No. So 2 is invalid, 4 and 6. So 3 are there. Then for 3, 3 and 6 are invalid. So 4 are there. For 4, only 4 is in. No. 2, 4 and 6 all are invalid. So 3 only. And then starting from 5, only 5 will be invalid. So 5. And for 6, 6 also there will be 3. So in total it is 11, 15. Wait, what? 18 plus 8 is 23 now. I'm missing something. For 1 5, for 2 3, yeah, 1 3 and 5 only. For 3 4, yeah, 1 2 and 4 5. For 4 3, 1 3 and 5. For 5 5, right? For 6 3, no, for 6 2, because 3 will also be valid. So is there some pattern right here? One and 5 will always have the equal number of. I mean, 1 cannot be paired with anything else. Similarly, 5 can also not be. And for 2 and 4, they both will be equal. Hmm. So in the case of 4, there can be 6 to the power 4. I mean, starting from 1, total possibilities are 4, are 6 into 6 into 6, which is 216, I think. Similarly for 2, 3 and 4 also. But how many of those will be invalid? That is the question. Okay, so like starting from 1, then so this cannot be 6, this has to be 5 only. This also has to be 5 and this also has to be 5 only. But one more thing is that it has to be 4, because like the first value, so this cannot be a 1, and if this value, let's say x, then this cannot be x also. So only 4 possibilities are there, and out of those 4 possibilities, and this will also be 4 because these two cannot be equal to this. So yeah, this also has to be 4 only. So total possibilities are 80, and 80 into 6 is 480, right? And out of 480, we have the answer as 184. Okay. Maximum XOR after operations. I mean, so a bit is set to 1 after some set of XORs if like the number of ones hmm, so if there is a 0, then there are some ones, so these two ones will cancel out each other, it will be 0, then 0 XOR 1 will be 1, and yeah, but we can also think of it like this, no? 0 XOR 1 is 1, then 1 XOR 1 is 0. Okay, so either way, its result will be 1, but if I include one more 1, then what will be the result? It will become 0, it will become 1, it will become 0, so answer will be 0 overall. But if the 0 wasn't present and also the answer was 0, right? 1 XOR 1 will be 0, 1, then a 0. So the number of ones should be odd. That means for a particular bit to be a set bit, there has to be odd number, there has to be the number of numbers that are having that bit as set should be odd. Okay, but like this and is a bit problematic, right? This and is saying that you can only decrease my value, you cannot increase my value. So I will use this AND operation or this whole operation when I want to decrease the numbers that are having a particular bit as set. Okay, so if I want to unset a bit, I will use this AND operation, right? This is all that I want to say. But there is no. Okay, so hmm. I mean, is there any benefit of doing the of performing this operation on a particular number more than once? So like in this case, it what x? Oh, we can choose x. X is not given to us. Okay, so now I think it becomes a little bit easier because okay, so yeah, so 7 is the answer for this case. Yeah, I think I just need to figure out how this 11 comes and I'll get the answer. So the 0th bit is set in 3 numbers. The first bit is set in 2, 3 and 2 in 3 numbers. The second bit is set in 0 numbers. The third bit is set in only one number, which is 9. So the answer is just simply this, which is 11. And if somehow I am having a okay, okay, so maybe I got the answer. Let's say 31. Yeah, 31. But yeah, I've created a 32, but the index will go up till 31 only, no? And then int I, while I is less than 32, if num and 1, then do vi plus plus, right? Else, yeah, else do nothing. Num right shift equals 1 and do I plus plus. Yeah, I think this should be. Then for int I equals 0, I less than 32, I plus plus. If like vi is greater than 0, so I think just vi should be greater than 0 and we'll always have an answer. I mean, we can include this bit in our answer. 1 left shift I, right? see out, not see out, return answer. Let's call it as long now, but I think int will also fine. 7 and 11, but I am not sure if this will work or not. Should I just go ahead? Yeah, doing it like this will ensure something. Okay, let's try it once. Cool. Oh, that problem was a nice problem, I would say. You are given an integer and for this problem I think about it this much. So how does that 184 came is the mysterious thing. So the the composition of 1 will be equals to the composition of 5, I think, and similarly the composition of 2 will be equals to composition of 4, and for 3 and 6, yeah, for 3 and 6 it's a special case. Okay, so I think I should break down that one. Also, first look at the constraint. So it is 10 to the power 4. Something like n log n will work, but not n square. Let's go full screen. So when I'm thinking about the 1, or let's first finish up the 6. So right, the first number is 6. Then 1 and 5 are the only two continuations basically. So 6 and 5. Right now, I think DP is involved in this thing. So after 1, yeah, so no need to compute for this one. The answer will be same. Like just this value multiplied by 2 and no need to compute this thing. So now after 1 we can have a 2, right? And we can also have a 3, 4 and 5. Okay, so here 2 and 4. So this value can be neglected because that is essentially the twice of this value. I mean, that will be equal to this value and the answer will just multiply this value by 2. So after 2, we cannot have a 1, right? We cannot have 2. We can have a 3. Okay, then 6, 1, 2, and a 5. And then we cannot have a 6 also. So 3 and 5, okay, we need to compute. Oh, but this is, yeah, this is the end. Okay, so this is just 2, then multiply in the whole answer. I will have 2 into 2. Now this thing and this thing, these two things are over. I have to compute the answer for this one and this one. Now after 3, I can have a 2. right? 2 and 4 and 5. So 3 values, 3. Then for this 5, 2, 3, 4 and 6. So 4 values for that thing. So it is just 4 plus 4, 11. Okay, and yeah, the multiplication of this by 2. So overall it will be 2. It will be 22. And now 162 is divided among 1, 2, 3, 4 and 5. That's interesting. So let's compute now for 1. Or let's first finish up 2 because it is easier. So after 2 we can have a 1. We can also have 3 and a 5. Right now after 1 we can have literally anything. 3, then 4, then 5, then 6 as well. And after 3 we can have a 2. We can also have a 4 and a 5. And for 4, not 1, not 2, 3 and 5 only. For 5, 1 can't be there, but 2 can be there, right? And 3 can also be there. 4 and 6. Okay, after this only 5 can be there. So it is 5 plus 5, 10 till now. For 2 it is, the answer is 10 currently. But now there can be a 3 and a 5. So for 5 the answer will be same as for 1. But for 3 the answer is different. Okay, so we'll have to compute it. 1, I think. So it is basically just some kind of a DP. Okay, so I think I should create some pairs or like some valid edges, I think. Yeah. Let's just call it as P. And P of length 7. So P of 1. Oh, so DP. Okay. So DP will be used for sure. So P of 1 dot push back what 2, or yeah, I can put a vector here. So there is a 2, 3, 4, 5 and 6. Now P of 1, P of 2 will have 1, 3, 4, 5, 6. No, 1, 3 and 5. P of 3 will have 1, 2, 4 and 5. P of 4 1, 3 and 5. P of 5 1, 2, 3, 4 and 6. Then P of 6 will have only two values, right? 1 and 5. So now there will be this recursive thing which will start from I, go on up till n, and there will be a previous thing, and these will be called, let's say, choices, but name it as P. Okay, so we have to take the modulo. For int pi in P, if pi is not equals to previous, then answer equals to answer plus recursion P I plus 1 and now this previous thing will be, oh, but yeah, there should be some current thing also. P of current. So the current value will be Pi and previous value will be current. Yeah, modulo mod. Then just return, I guess. Hmm. Oh, but there is a problem. So if I reached here, then I should return 1. Yeah. And for int I equals 0, I less than 6, I plus plus, answer equals to answer plus recursion P, I will be 0, n will be n. Previous, let's say 0, and current is I plus 1, modulo mod. Then just return answer. And here I need to implement that dp thing. For int I, previous and current. So if dp of I, previous and current is not -1, then just return it. And let's have it here. N plus 1 7 7 and -1. That what? Hmm. So this should not give me the compilation error. Still, oh, these are warnings. Did what? Expected semicolon after expression. I mean, what's wrong with it? 516 and 66. Oh, so this should have been 184 and cool. Yes. So I was slow. I was very slow today. Maybe because my last few Leetcode rounds were not so good. So I was just trying not to get any bugs like these. Yeah, today the problems were okay, were not bad. So let me just quickly explain my solutions as well. For this thing, count asterisks. It was like just a brute force way of solving the problem. Initially, I am having like this boolean flag. So since it is true, I can count the asterisks in my answer. And if I encounter any this bar, then I will just flip the value of my current flag. Like if it is true, then I will switch it to false, else to true. So like let's run it for an example as well. So when I'm having this L, the control will go all the way here. It will check if it is equal to asterisk. No, it's not. Will not do anything. It is a vertical bar. It will flip the value of f. So now f will become false. Now there is an asterisk. It will come here. Since f is not true, it was set to false in the previous iteration. So it will not count it in the answer. Now for this e, it will come here, but yeah, for it will not do anything if it is not a bar or an asterisk. And then again we will encounter an asterisk, but f was false, so it will not count it in the answer. Again e and t will do nothing. For this bar, it will flip the value and now it will become true. So now all the further asterisks will be counted in the answer. So now Now the count of answer will be increased and answer will become 1 now. Then again for this asterisk, that will also be counted, answer will become 2. And for this bar, value will get flipped of the boolean variable. It will become false and will not count this asterisk. At the end will be switched back, but there's no point. Like it will not affect our answer because the string is ended. And yeah, the answer is 2. So this was a easy problem. Now count unreachable pairs of nodes in an undirected graph. This was a decent problem, I think. Or like it is not a bad problem. It is a good problem. So how I solved this problem is that first I created the graph. So for that I just converted these edges into a standard adjacent edges vector of vector like this. And then I run a DFS. So through that DFS I figured out all the connected components and I assigned some ID to each of the values of a particular connected component. So like when I will do DFS for this graph, I will start from 0 and will traverse all these values 0, 2, 5 and 4, and I will assign some ID. So for that graph, ID of 2, 0, 2, 4 and 5 will become 0 because that was my 0th connected component, you can say. Now for this 1 and 6, like I will visit the vertex if it was not visited in the previous iteration as mentioned over here. Like it is a very standard way of finding connected components. So if you know how to find the connected components using DFS, you can understand it immediately. And if you can't, then I'm explaining it. Then for 3, it is my third connected component and the ID will be assigned as 2. And similarly, I will also fill like 0th ID has been assigned to 4 vertices and 1 ID has been assigned to 2 vertices and 3 and ID 2 is assigned to 1 vertex. That is I am counting over here. Here I am assigning the ID and here I am marking that the current node has been visited. And then just doing DFS for all the unvisited children of the current vertex. So like when I will do the DFS for 0, 2 and 5 are the unvisited children of 0. So I will do DFS for 2 as well as for 5. But when I do the DFS for 2, it will visit 5. So like when I will check if 5 is visited for 0 or not, so it will not be visited. It will be visited, so it will not visit that again. All in all, I'll get a connected component that will have 0, 2, 4 and 5. Okay. And then, yeah, then just doing this thing. Initially, I was troubling. Initially, I was like not able to think about this thing, but yeah, I soon find out and it was just easy. So what I did is just that first I took the sum of all these values, which will be n obviously. So initially the sum is n. Then since we just want to find out the number of pairs of different nodes that are unreachable from each other. So like for 0, 1, 6 and 3, all the nodes that are not in the current connected component and were not a part of a pair before will be counted in our answer. So like for 0, 1, 3 and 6 will be counted in the answer, I think. Yeah, so the sum will be whole this n minus the size of the current connected component or the number of vertices that were in the connected component of 0 and are not visited currently, right? So that is currently 4. So I will add um, in the answer I will add sum minus 4, which is just 7 minus 4 and which is 3. And then for 1, what I will do is that sum minus count of IDs of the current vertex. So sum is, yeah, I have decreased the sum also by 1 because 0 has been visited now. So it should not be counted in any other pair. That will be finding out later for the other vertices. So now doing some minus minus and also saying that one vertex of the connected component of IDI has been visited. So that way I'm subtracting 1 from this as well, decrementing the value by 1. And then I will do 6 minus IDs of I. So in the case of 1, it was just 2. Do minus 1 and it will become 7, I think. This way you can iterate over all the values from 0 to 7, 0 to 6, and you will get the answer. This was the tricky thing. All the other things were just standard things. Okay. Now maximums or after operations. This problem was an interesting one, and if you saw the screencast, then you know how I solved this problem, how I got to this answer. So you can just go back and see how I solved it during the contest. So what I am doing basically is that for each bit from 0 to 31, since the value can go up till only 10 to the power 8, so I think 30 or 31 bits doesn't really matter. I mean, it does matter, but since I am taking 31, so it will not matter. Then for each bit, I am just counting in how many numbers that bit is set. So like 0th bit is set in how many numbers. So why are we okay? So I will explain why are we doing that. But let's first have that count. So for this example case, so yeah, I have written it over here as well. So for these values, 0, 0th bit is set in 3 values, first bit is set in 3 values, second bit is not set in any value, and third bit is set only 1 value. If you think about it, think about this operation, you will soon find out that there is no way to set any bit. You can only unset a bit in any particular number. So what do I mean by that? Let's say you have a number, let's say you have 7. So 7 is represented in binary like this, 111. Now essentially what you are doing is that you are having some other number, doesn't really matter what it is, let's say 98, and then you are doing the AND of it. So like you are doing 7 and 98. So what it will do is just that it will unset the bit which is set in 7 but not set in 98. The definition of AND operation basically. So the key thing is that AND of A and B cannot be more than minimum of A comma B. So it will always be less than or equals to minimum of A comma B. So this was the key thing, and then you can do this problem very easily. And later on the observation was that if the bit, so like if the first bit is let's say set in two values, then if you just do the XOR of those two values, so 1 XOR 1, like XOR of 1 two times, so it will be 0. But doing some XOR operation, you can unset the bit in one of the numbers, so then it will be 1 XOR 0, which will give me a set bit. And since we want to maximize the final result, so a number will be maximum if the bits are set in that number, right? So if the bits are, let's say the number is this 1 0 versus 1 1, then obviously 1 1 is bigger than 1 0. So we want to maximize the number of set bits, and that to the most significant bits must be set. Like if those are set, then obviously we'll have a bigger number as our answer. So yeah, in the end, just if a bit is set in even one of the numbers, then that will be set in our final answer. So I think the answer was just the end of all the numbers. Like in this case, the end will be 7. Both, not the end, but the bitwise OR of all the numbers. In this case, the bitwise OR will be 11 only. So yeah, you can do this, or maybe I think I should do that. So answer or equals to num. Yeah, just this thing would work. I don't know if that will affect my standings. Like I have never submitted a solution twice. Yeah, just the bitwise odd of all the numbers will also give me answer. I was doing, I was also doing the same thing, but in a complicated way. So like if a bit is set in even one of the numbers, and I was just setting it in the final answers. So that was it for this problem. Now this number of distinct roll sequences. Again, if you have seen the screencast, you will understand why I did this thing, but still I will explain. So these values are just, oh, these values are just saying that if the current number is 1, then the next value can be any of these 5 values. If the current number is 2, the next values can be any of these values. So the first thing that you need to realize is that although they are saying any adjacent values in the sequence, but they just mean that just means that if the bitwise, if the GCD of any two numbers, so like any two neighboring numbers in the sequence, let's say the sequence is this. So since the sequence of 2 and 1 is 1, so like the like this we have to maintain the GCD equals to 1 for every two numbers, every two consecutive numbers, adjacent numbers basically. So like the GCD of 1 and 2 should also be 1, GCD of 2 and 3 should also be 1, and GCD of 3 and 4 should also be 1. So what that will do is that if the GCD of 1 is 1 comma 2 is 1, and GCD of 2 comma 3 is also 1, then GCD of 1 comma 2 comma 3 will automatically be 1, right? This thing you can prove that mathematically as well. And after that, yeah, after that it is just DP, and I did it in the recursion plus memorization way. So PI is denotes basically the available choices given that the current number is equals to cur. And then if PI is not equals to the previous number, which is given over here, that the distance should be 2 at least. Like in this case, 1 is repeated after only one number, so that is not valid. So if the 1 was here like this, there are two other numbers in between the ones, then it was fine. So that condition has been checked over here. then I'm just adding the result for these, for the other choice. So this way, if I have reached the end of the sequence, that means I am having a valid sequence. So I will just return one, add an answer modulo mod, store it in the DP vector, and return the answer. So this was it for this round. It was nice, and I don't know if I will be doing the morning round tomorrow or not, but this was a nice round. So thank you all. I'll see you tomorrow. Bye.